Right, today I'm going to be showing you my no fuel furnace design. So basically, as it suggests, it doesn't require any fuel to operate. You can utilize fuel if you want, but you don't actually need to. So the way it works is that ingots and ores that have that off gas, they cool down a furnace. The ores that off gas, they cool down the furnace by generating cold gas. Um, Ingots delete heat when they processed as reagent into a furnace. So the way it works is the furnace will start off in melt mode, which means that it's just opens to this alpha tank here, which you need to maintain between 160 degrees Celsius and 277 degrees Celsius. That will ensure that the reagents get properly processed. The alpha tank will also process solder and wasp alloy because of the temperatures that those require. So basically, all ingots except for this furnace will can create all of the current ingots in the game except for the solid fuel hydrocarbon ingot, and that's because they all come within the range requirements except for that one ingot. They come within a varying ranges of pressures. However, they come under 4 temperature sets. So I only need 4 tanks of specific temperature gases, and from there I can then adjust the pressure utilizing those gases to smelt the ingots, smelt the material. So you put the material in, you put it into smelt mode, which connects with the alpha tank. The alpha tank needs to be have its heat regenerated. It also needs potentially cooling and pressure relief. The off gases from the ores can generate fuel, which can obviously generate heat and pressure, but equally they will generally cold gases will be spawned, or the ingots will delete heat from the alpha tank. That is a completely separate thing that you yourself need to come up with a system for that to prevent overpressure and to keep the tank at the correct temperature. I'm not going to throw that into this because there are many different ways of doing it, and it depends on the world that you're currently on. So maintain this temperature set here and make sure the tank doesn't overpressurize. So let's get started. Let's set up the chips, shall we? Stack filler. Start loading that up. So the first the furnace chip. Export that. Place it in there. Turn it on. Wait for it to come until the state goes 0. Pull it out. Put it back in here. We're going to now load up the proper script itself. It is important to load up these scripts correctly. So the stack filler is the same for both the advanced furnace version and the normal furnace version of the no fuel furnace. However, the rest of the scripts are separate. They are different between the two types of furnace. So normal, let's see, advanced no fuel furnace, pump controller. Load that up. Export it. Put it in. The furnace is now going to start setting itself up. It's going to start preparing itself going into melt mode. Assuming, obviously, you've set up the furnace. As you can see here, I'm not going to go through building it bit by bit. That's just tedious, and I find it a waste of time. If you follow this, if you fully watch this video, listen to everything I say, follow all the hints, the instructions, you can set it up fine. The tanks, the pumps, turbo pumps here, and the active vents do all need to be named correctly. These signs I've put here are for easy reference. They're not actually called Alpha, Bravo, Charlie, and Delta themselves with the labeler. They are called, the Alpha tank is called 10 or 10. The Bravo tank is 2, Charlie is 3, Delta is 4. And all the corresponding pumps and active vents need to be the same. So the Alpha tank has tank 10, has pump 10, as is connected via this line here, and connected to active vent 10. The Bravo tank, or number 2, also has pump 2 and active vent 2. You get the idea. Rightio. Now, advanced furnace UI control scripts. And laptop, export it, plug it in, turn it on. Rightio. This furnace is now ready to go. Let's set up the other one. Stack filler. The stack filler script has some instructions and some helpful information at the top. Helps explain what's going on a little bit. Export. Run it. Wait for it to run. Pull out the chip. Bring it back over. The stack has now been loaded. Now normal fuel, no fuel furnace, pump controller. Export. Put it in. Furnace is now starting to prepare itself. No fuel furnace, double pump UI. User interface script. So these do have pins. I've previously set up the pins to save a little bit of time. I don't need to show you how to set up pins, surely. Hopefully. Right. So this furnace is also set to go. So the normal furnace is a bit faster than the advanced furnace version because of the pumping limitations of the advanced furnace. It used to be a lot faster before the phase change changed the volume of the piping and the pumps, but it is still mostly a bit faster than the advanced version. It just can't create the super alloys because the normal furnace has been hard coded by the devs to not allow you to create super alloys such as Astraloy, Inconel, Wasp Alloy, Stellite, and Hastaloy. It is important to utilize reinforced windows to surround the furnace. This is to insulate it, and you utilize the reinforced windows specifically because the temperatures that the stellite requires cannot be insulated fully with only standard pressure, 1 atmospheric pressure of approximately 101.325 kPa, as the other metals can. The way it works is you process the materials utilizing heat from the alpha tank. Once they're processed, then you select the material, and then it pumps in the preset gases from Bravo, Charlie, Delta, or even Alpha if it's still solder and wasp alloy. And because it's fully insulated, because the heat deletion part has already been done, the Bravo, Charlie, and Delta tanks do not get a loss of heat energy at all if you set this up correctly and utilize it correctly. So currently it's in melt mode, or orange. As you might have seen earlier, it went blue initially. That was the telling that the furnace is going into a new mode. It's preparing itself. Orange is melt mode, solder, and wasp alloy mode. Red is when it is removing gases from the chamber and the furnace in order to go into a new mode. That's red. and it is green when it is in a new mode, ready to expel the materials when it is not solder or wasp alloy. It'll just stay orange for them. It is important to note that it is very important that you make the piping from the tank to the manifold over here with the pumps. The piping needs to have a volume of 110 liters or greater on this one here. On all of these, it needs to have 110 or greater. The manifold here, which is between the pumping and the furnace itself, needs to have a volume of exactly 1,000 liters. Exactly. I achieve this by utilizing the inline tanks here. These are uninsulated. I believe insulated versions are coming soon. However, I only have access to the uninsulated versions for now. So it's important to have a manifold volume of 1,000 liters exactly. And that the inline tanks are inside the insulation box because they're not insulated. These inline tanks aren't. Let's see. So let's start making some material, shall we? Everything here is deliberately set up. The silo is there specifically because in conjunction with the scripting, it will prevent you from adding in materials into the furnace accidentally when the furnace is not set up to. If you were to add materials to the furnace when it was not in melt mode, you're going to affect the other tanks, which need to remain constant. So let's start with some silicon here. So this is the hold lever here. So I'm going to pull that there because, let's see, so drop the silicon in. So, right, it's processing. As you saw there, the important button closed itself, and it did also lock itself at that time. That was to prevent you from trying to change the mode while it's processing ores. Because I'm only running a small amount because it takes a shorter amount of time to process. I don't want this video to go forever. So that's why I just panned down for a moment, because it only took a moment to process. Once it finished processing, it opened itself back up so that you can change it. Now, with the hold lever up, it should prevent it from changing modes. So I've changed here, I've selected on here. So if this hold lever was not pulled, once it had finished processing everything, it had detected that it was no longer processing any more materials, and the selection was not set to 0 or blank there, then it would start progressing, it would start changing its mode into the whatever selected. I could also manually press that, which will bypass that, or I can just put that back down and it will continue as it would have otherwise, which is automatically changing itself. So the color's changed, it's locked itself there. Go around here, the silo is closed itself, it is locked. I cannot open it. That is one of the many safety features within the script. It is now vacuuming it out, and I have until it is all finished going from the red until the mode changes from red to blue to select dial correctly. So I can keep changing that around to whatever I want. There. Now I've selected steel because the steel setting is made for anything steel and below. So all basic ingots, nickel, lead, iron, gold, silver, silicon. So that started processing. Right, let's do some advanced alloys here. Well, that's continuing. So let me just pull that lever, because having that lever up when it goes into smelt mode will prevent the furnace from auto ejecting once it is ready. That will go green once it is ready. It goes to its thing. It So initially, earlier when it was going red, it vacuums out the furnace, then it vacuums out the insulation box. So look at that, it's vacuuming out the insulation box. Then it will, now it's going to blue because it's now preparing it. So now it's going to fill the insulation box back up with the appropriate gases. Once it reaches that, then it will start pumping and fill up the furnace again. It's now green. It is ready to eject. If I just let that lever back down, that holds it, prevents it from auto-ejecting. If I didn't have that lever up, it would have auto-ejected as soon as it went into it finished setting itself up as it currently is. There you go, smelted silicon. It now starts vacuuming itself back out. It's gone red. It's vacuuming out the furnace. Then it will vacuum out the insulation box, and it will go back into melt mode. It'll go back. It'll fill up the insulation box with alpha tank gases, and then open up the digital valve to constantly transfer thermal energy gases with the alpha tank. Let's see. Let's go. Let's make some astraloy, shall we? So now I'll just let it do its thing. Okay, so now because it's not on zero, because it's still on zero, it isn't auto changing mode. Otherwise, I've changed it off of zero. It's now starting to change mode. I now, as I mentioned earlier, I now have until it's finished red phase doing its thing when the LED is red in order to change to the correct setting. So let's see, where was I? I was making astraloy, number 3. There we go, astraloy is now set. I will not pull the lever there, so it will auto-eject once it is done. Once it's changed mode, it will prepare itself, and then it will eject the completed astraloy. Gold. Let's go with gold. Set it to steel again. There we go. It does take approximately 2.5 minutes to 2 minutes and 40 seconds for the advanced furnace version most of the time to change modes to go from melt into smelt and then be able to eject itself. So yeah, so if I pull the lever there, it's not going to auto eject once it is ready. So I can walk away now because it's outside in this particular instance. I can walk away, come back an hour later, it's going to still be ready to go. I would just lower the lever and it would eject at that time. Preferably you don't leave it in anything but melt mode for extended periods of time. And notice that once it does eject the material, it does automatically change itself back to melt mode. So smelt mode is any other setting for materials except for melt mode, which is when it's in orange. So yep, so it's now filling back up. So it's filling the insulation box to make a perfectly insulated environment for the furnace. Now it's going to start filling up the furnace in a moment. What's going on over there? That one's still going there. So let's see, astraloy. Astraloy requires 30 to 40 MPa. There we go. It's gone up, it ejected, and then it immediately started taking itself back into melt mode. There you go, astraloy. Silicon. There's the gold. Right, there's the silicon there. There's the gold. So it's taking itself back into melt mode by the looks of it. So it automatically reverts. Once it's ejected its materials, it automatically puts itself back into melt mode, ready to accept more materials to smelt again. So everything gets everything that needs to be locked gets locked from the get-go. So all of this is all locked. I can't affect this stuff. I can't affect the silo at all. It's the script. It's locked the furnace itself, and it locks. And as I explained earlier, I believe it periodically locks the important button when it would be disadvantageous to operate it, but unlocks it again when it does want to let you operate it because it's not in such a state that operating the important button would cause problems. Right, it's back into melt mode again here. Right, let's make some invar. Right, invar is number 4. There we go, this is back into melt mode. Let's make something else. Let's see, Inconel. Oh, whoops. These proportions are incorrect. I made them boo-boo earlier. Little mistake. Right, Inconel, 5, 5, 10 gold. Yep. Right, I've got my correct proportions now. And obviously you can make as much as you want. I'm just using small proportions, small ingredient quantities in order to expedite things, because it would just take too long to process the reagents of anything in large quantities. What was that, Inconel, wasn't it? Yes, Inconel. Number 5. There we go. So yeah, so when the furnace is not in melt mode, the silo is closed and obviously locked. Hang on a minute. Just a minute. So you can see, same over here, so there's the alpha tank, here's the Bravo tank, Charlie tank, Delta tank. Obviously it's a bit messy here, but clean it up as you need. Just make sure you follow the basic instructions that I did set though. And try and use a little bit of common sense. So for instance, do not connect the active vent here to the point in the manifold itself, not before. Make sure you connect them before the pumps and before the digital valve. Something seems to be going a little bit hinky with this for some reason. For some reason now it is having a little bit of an error and having trouble changing to the correct mode. I will have to figure out what on earth is going on here. Yeah, I'm just going to go back to 0 for a moment, maybe. Rightio. Well, there's the ink canal that I was just creating. Let's see, what's astraloy ink canal? Let's make some wasp alloy. Let's preset this time. Wasp alloy. Pull lever. Drop my ingredients in. I hope it's not in melt mode just yet. That's alright because the silo is closed. Prevents it from putting it in until it's ready. Let's see, it's gone back into melt mode. Good. Now what did I try to make again? I think it was Invar. Number 4. This is that high pressure one, needs 50 MPa and above. Oh no, it has gone, it's green for that, yep. And it will probably go, I believe it's orange. Maybe green, I believe it's orange. Green, it's ejecting itself, and it's resetting itself, going back into melt mode. Oh no, still stuck in melt mode. That's right, I got the timing correct earlier. I was getting ahead of myself. That's my mistake, not the furnaces. But that just shows you how robust the system is, because it wouldn't let in the materials into the furnace when it was in the incorrect mode, and would have deleted heat or otherwise added cold gases to these tanks that need to remain unaffected. It is important, if you do set up these two separate furnaces that they be on separate data networks, because they do utilize a lot of the same commands for the same named equipment. So just ensure that they're on separate data networks. It's gone back there, yep. It's now processed the reagents. Cool. Now, what was it again? It was wasp alloy, that's right. Wasp alloy was number 7. Yep, so that'll be going there. Just going to pull that lever there. I believe I may know what the issue is over here. Just may need an additional yield in the particular part of the script for the UI control on that one, just because of how quickly it's running relatively. But that will be fixed up before the script goes on the workshop. I believe it's just a very quick alteration. But as you saw, it worked on the other alloys. It's just a small hiccup that just wants to show itself just occasionally. But I believe I know how I might be able to bypass it for now, until I can make that alteration to the script. Right. Going to manually go into the mode. And hold that. Radio goes blue. It's going into wasp alloy mode. This moment is just taking a sweet time. Sometimes it does that, unfortunately. Let's see what's going on over here, shall we? Here we go. What's going on over here? I should eject in but a moment. There we go. Now it's reverting itself back to mount mode. So there's the wasp alloy. Let's put in the next one, shall we? Haste alloy. look at that now. Yeah, that's right. I'll have a look at that later. Actually, hang on. I might have. Did I accidentally? No, I didn't, did I? I don't think I did. Just talking to myself. Okay. So I should have now processed. Yep, it's in there. Its reading is in there. What was it? Haste alloy, that's right. Number 9. There we go. It's going to go process the haste alloy now. Uh-oh, we have a storm incoming. Well, I'm just about done anyway. That's a half LED furnace. Just a moment. There we go. And we'll spit it out in 3, 2, 1. Bam. Alright, I'm going to call it there, folks. Before the storm comes along and blows all my lights around and stuff. Rightio, thank you for watching.